Hi, in this video we're going to look at calculating the distance between two nodes on a surface. So this will be a SUMA based calculation. Alright, in this directory here, AFNI data 6, FT analysis, and then the SUMA output here, what we're going to do is we're going to look at two examples. One which is slightly interactive, so we'll kind of copy and paste in the terminal, and another one which is really fully scripted, which may be a better way to go if you have lots of points to calculate the distance among, or slightly more automated. So I'm going to open up this script here, do02 SurfDist, the basic example. And as this notes here at the top, this is just meant to be interactive, so we're going to kind of copy and paste and see what happens as we go along. Okay, the directory is noted here if you've set up your bootcamp data. So first, let me just clear my terminal here. What we're going to do is we're going to look at defining two endpoints for the calculation. Now, the surfaces that are output by @SUMA makespec name of program, wherever you get your surface from, so translating the mesh into AFNI and SUMA, are standardized, which is great. So in this case, what we're doing is we're starting with two XYZ locations here. And I actually did this by finding some points by opening up AFNI and SUMA and having them talk together, and finding points that were near the surface. Now, these points are not necessarily on the surface itself. So what we're going to do is we're going to first take these coordinates and then identify the nodes that are closest to them here. Okay, so these are somewhat arbitrary choices, but I picked points that are kind of near a surface point. Okay, so I'm just going to take these commands here and copy and paste them into the terminal. All right. And now if there should be a file here called xyz1d, and if I type cat and the name of that file, that just displays it. And so my coordinates are here, xyz, xyz, each in one line. And something to note here is whenever you see these coordinates, it's not good enough to just know plus, minus, and these values. They're in XYZ order, fine, that's standard across all software, but whether the minus sign here for the X coordinate means are we on the left side of the brain or the right side of the brain, you need to know which coordinate notation you're using. By default in AFNI we use RAI DICOM, and for us this means that the negative sign for any one of these coordinates will be either the R, A, or I of it. So this first coordinate, which is the X coordinate, is negative, so this means it's on the right side. Is this anterior or posterior? It's positive, so I know this posterior, and this -3 means that this is inferior. And this is the same hemisphere, the right hemisphere, posterior, and slightly superior. Okay, so if that's confusing, there are other AFNI videos that kind of cover this, but you should be able to look at these knowing this information and get a sense of where the 2 points are that we're going to calculate the distance between. All right, so now we need to find the nodes that correspond to it that are constrained on the surface, and that's what this command here is for. By default, again, everything in AFNI by default I believe is RAI, or I'm sure there's some exception somewhere, but 99% of the programs are. I specify it here again explicitly just to be clear. Then I load in two surfaces. I didn't even need to load in both. Since I knew that this is in the right hemisphere, I could have just loaded in one, but I loaded in both. Since there are multiple ones, this qualifier here has to match the order. So left hemisphere, then right hemisphere in the order of these input of surfaces. Then for if either of these points is found on this surface or this one, on this surface it would get an L, and on the second one it would get an R. If I had a third surface, let's say there were a cerebellum surface or something, I might call that with a label then C, and that would correspond to that surface. Okay, hopefully that's clear. So now I'm going to copy and paste this here. Okay, And this command just produces output visually into the terminal the way it's run. I could redirect it into a file and do different things. In the advanced script we will, but this just tells me two pieces of information. This tells me the index of the node with the kind of qualifying surface, so I know that each of these, it's one for one, so each of these points is found on this R, the second of the surfaces I input. And this tells me the distance from my XYZ location to the XYZ location constrained to the surface. So basically, this point that I had picked was quite close to the surface, and this one was still fairly close, about 2 millimeters away. Okay, so there we go. Now what I have to do is I want to take these node indices and put them into a text file, and that's what I'm going to say, okay, now take these two values and calculate the distance. So the way I'm going to do that is I'm just going to echo each one into a text file, and as noted here, just for the next command, it should be called nodelist.1d. So this means take this text that if I just say echo this, it would be displayed in the terminal, redirect it or dump it into a file called nodelist.1d. And just to prove that that's been created, it's here, and if I cat that file, it just has that information there. Okay, so now basically what we've done is we've started with taking two XYZ locations, and now we've made a file that has two node indices in it. These string characters here, actually, when I first did this, I removed them. I'll see, actually, those are ignored by the program that will read this in. So you can just leave those on here. That's okay. All right, then what does the next command do here? Well, now we actually want to calculate the distance, and that's what this AFNI program, SUMA program, SurfDist does. So we're going to input the surface along which we want to calculate it, which is this one. And notice that I'm using the same surface from here. Since only one of these was involved, I'm only inputting the one surface here, the right hemisphere. So in this slightly interactive example, I have to kind of pay attention to whether it's a right or left hemisphere. So I'm inputting this surface. Now note, if I picked a surface of a different state, this is the peel surface. If I picked a different one, then I could look at the inflated. I have all the ones I could choose, the kind of inner gray-white boundary, the outer gray matter boundary, the peel, things like that. So we really have to know which surface we want to calculate the distance along, because it will matter, because the surfaces have different geometry, and now that we're calculating distance is a geometrical property, or geometric property, one or the other. And then this is kind of an extra option here. This will also output a list of the vertices, so we know the path along the surface, and we'll be able to display that later. And finally, this option, the minus graph, if I just show the, well, anyways, I won't. The SurfDist, you can calculate the Euclidean distance, so I could say, now that I found these distances here, what is the distance just on a straight line through the brain from point to point? So ignoring the surface not constrained. That's one way you can calculate distance. Here, we're going to calculate it along the graph. So if I'd put here Euclidean instead, it's a separate option you can see in the help file, then that would be a different distance. Here we're using the one constrained to the surface. So I'm just going to copy and paste this here. Okay, and it ran, and it told me some information, and it displayed that going from this node to this node, which are just the ones I had here, this is the geometric distance, the graph distance, actually. Okay, so it's 73 millimeters constrained along the surface. Okay, and it reminds me which surface that I had picked. All right, cool. So that's the information we wanted. If we want to display this, we can run SUMA. So this command here, if you remember from other driving SUMA discussions, that when we're driving SUMA and providing more than one command to it, we usually specify a port number that it's communicating on. Here, I'm assuming that there aren't any other SUMAs or AFNIs open, so I'm just being a little bit carefree about not specifying a port number. I'm just going to copy and paste this, it opens up SUMA, and this is the peel surface, kind of what I'd call the outer boundary of the gray matter. And we don't have our points there yet. You can see that's just the crosshair randomly. Here's the peel surface. To display what's called the displayable object, the path that we'd made here, now I'm just going to copy and paste this here. Okay, so it says that it did it. And now I see there is the path along the peel surface. Okay, so this was one point here, and here's the other one somewhere over here. And actually, if you want to see what that SurfDist file looks like, it's just basically a list of the line segments as it goes along, and this is so this is vertex to vertex, and I think this is color and opacity. Okay, so there you go. This is one way where you can calculate the distance and then also visualize it along a surface. If I had chosen a different surface here at the beginning, let's say I chose a different mesh density or a different state of the surface, maybe I chose the smooth white matter or something like that, then I would get a different distance along the graph. I might even get slightly different node numbers because the point on that other surface that's closest to my input location, each of these was slightly off of the surface. So the closest point could theoretically be a little bit different on different surfaces. So you really have to be careful that you know what you want from the beginning, and then you have to keep using either of these surfaces later. I can't suddenly go here, I want the 141 one here or something like that to calculate the distance. If you wanted to display something different, instead of just inputting one surface, you could open up this, you could drive with the specification file here and then choose a different state. We'll see that in the next script, so maybe that'll be slightly clearer. All right, so now I'm going to open up the second SurfDist example, 203 here, where actually there's now many points. What happened? Oh yes, so I have to provide the -e to say open this up in a text editor so that the command knows. So AFNI open -e and then this text file. Okay, in this script now, this is actually all entirely scripted start to finish. So anything that would be displayed in the terminal is grabbed here using shell scripting and then dumped into text files and things like that. So we'll walk through the script first to see what it does. And this might be a little bit more programmatic example now that we're familiar with the steps that it has to take. So first, because we want consistency, what I do now is I define variables to say which of the standard surfaces that I want. So the number of points in the standard that defines it. It's actually it's something related to the square of this, but so I want the standard 141 surfaces. And here again, I'm just choosing to calculate distance along peel. But if I wanted to change it, what I could do is I could specify it here once, and then this variable surf type would change everywhere consistently, so I don't have to hunt for those in the code. Okay, so just defining that. And now here, I'm actually going to choose a larger number of points, and we're going to calculate the distance between any possible pair of points. Now there are 8 points here. Those who are carefully observant will notice that the minus sign in this column changes a bit. So everything is kind of echoed. These bottom 4 are the same as the top 4, it's just the sign here is different. So these are basically similar points, except this is on one hemisphere and this is on the other. And as a quick pop quiz, if these have negative x value and RAI coordinates, are they on the right or left hemisphere? Well, again, RAI DICOM notation in AFNI means if you see a negative sign on it, it's going to be one of these. So these are on the right hemisphere here, and then these would be on the left hemisphere. The branes, and this is not necessarily a symmetric brane, so actually we don't expect necessarily the node indices for these points because these are specified XYZ coordinates near the surface. We don't know that they'll be the same index and everything. So anyways, The script below will sort out which one's on the left and right hemisphere, actually. Okay, and then any possible pair. So among these, any of these could be connected by a distance, so we'll calculate the distance between this one, A and B, A and C, A and D, B and C, B and D, etc. And same for here. And we won't be able to calculate the distance between here and here because they're on different surfaces. Okay, moving along. Then the next command was, once we have our XYZ locations, we need to find the points on the surfaces that are closest to each. This command will do that. Now this surf to vol coordinate here, so projecting the coordinate onto the surface, it's put in these backslashes and set in, kind of dumped into this variable because we're going to store this information and use it. So I don't want to have to kind of copy and paste from the terminal. So I'm having my script take all the information, save it to use later. And what's going to happen then is I'm going to define a node list for my left hemisphere and right hemisphere. Right now these are empty arrays. And this will go through all the information in node info. So it's pairs of information. This is going to go through every other point and find out whether it's a node index on the left or right hemisphere and save it to the appropriate node list. So if you're happy with shell scripting, you can read through that a bit more, but that's what this is going to do. So this will kind of separate out which node list is on which hemisphere and put just the index into the text files to get the pairs of. Actually, this just separates it out, and this next loop for the left hemisphere node list will go through, and this is a set of nested loops. So it will calculate all, or it'll make into a text file all the possible pairs of points whose distance I want to calculate. So it'll go A to B, A to C, A to D, B to C, B to D, etc. And if you put in however many number of points you put in up above, it would do that for them. So it's kind of generalized in that sense. This is the same thing for the right hemisphere. And then here, for each hemisphere, we're going to calculate the surf distance on each of those files and save all of them into a 1D file. And then here's the information that we can view. This will open up the appropriate hemisphere specification files. Now, what this will do is it will go to the inflated surface. So it'll move through two of the states to what I know in this case, the second one is the inflated surface, and then it will load the display object so I can see the path along the inflated surface. Because it's easier to see things there, so we don't have to deal with the sulcal and gyral stuff, the geometry. Okay, so that's just, I know reading scripts isn't the most fun thing, but there you go. Now you can look through this later and kind of see what's happening there. So I'm just going to run tshell do 03. And there we go. So it's found things, it's calculated distances, it's opening up SUMA, each hemisphere, and I see lines there on an inflated surface. So here we go, control right, and control left. Okay, and each one of these lines corresponds to and from one of my 4 points here. So there, I'm sure there's a point here, there's a point here, a point here, and I think what happens is some of these actually overlap a little bit. So I probably could specify some opacity and see that. But here you go. Here are all the possible pairwise distances on each hemisphere. There are 4 points. So on each one, there should be 3 plus 2 plus 1, 6 lines. So 1, 2, 3, 4, 5, somewhere 6. Okay, there you go. That is how you can calculate the distance and lines between points in kind of a generalized way. So these scripts are there to be read and examined a little bit more.